This is Barry Zalma on insurance. When considering the defense or prosecution of a construction defect action, or making a claim to an insurer as a result of a construction defect, it's necessary to first understand basic construction. Building codes prescribe basic standards. When these standards are not followed, or not followed carefully enough, a building can fail. It may leak or lean or even fall down. The basic component parts of a standard dwelling, built of wood framing using common construction methods used over the last century, and the problems that can arise when any part of the building fails, is the subject of this video. To make things simple, we'll discuss single-family dwellings. Multi-family dwellings and commercial buildings are larger, have more parts, and are much more complex to construct. Newer building materials and techniques are not discussed, nor are factory-built homes. Note that modern buildings may use steel in place of lumber in the framing because the cost of lumber has accelerated exponentially during the first year of the Biden administration. Artificial rather than cement-based stucco can be used. Computer controls for electrical appliances and heating, ventilating, and air conditioning systems and other modern materials and construction techniques seem to be used more frequently. Regardless of the materials and techniques used in construction, the points at which the structure may fail are essentially the same. Typical single-family homes built during the last century were constructed with a wood frame built on top of a concrete foundation. The foundations are either raised on piers or poured flat on grade. The lumber that makes up the wood frame is usually jacketed with lath, thin wood strips, or a moisture barrier paper with wire covering that is covered with stucco, a durable artificial porous concrete product. Exterior insulation and finish systems, such as artificial stucco or wood or vinyl siding, add to the exterior of the dwelling. The interior walls are usually finished with drywall, gypsum covered in paper that when finished gives the appearance of lath and plaster, or in older structures, wood, lath, and plaster. Some even use what is known as button board, which is, instead of using gypsum, uses concrete, but works the same as drywall. Basic single-family dwellings are usually 1 to 2 stories in height and range from 900 to 3,500 square feet. Of course, there are mansions where a single family may reside in a 20,000 square foot structure, and McMansions that range from 3,500 to 10,000 square feet built on lots where most homes are in the single family size of 900 to 1,500 square feet. It is becoming common to remodel old dwellings and increase them to 5,000 to 10,000 square feet on small residential lots. These extreme remodeling efforts often run afoul of claims of code violations and construction defects. The component parts of a single-family dwelling follow. First, there are footings. Concrete footings are the base for the foundation upon which the dwelling is built. They are poured in forms using a 1-2-4 mix of concrete and reinforced steel of various sizes. Failure of footings can cause the dwelling to sink, slip, or lean, causing plaster walls and stucco to crack, roofs, windows, and doors to lose their watertight seals, and doors to creak, all of which will eventually cause the owner to complain to the builder and or file suit against the builder or developer for what they claim to be construction defects that have destroyed the value of the home and caused the expenditure of a great deal of money to fix the problems. Spread footings are constructed with a wide base that helps create a large area to transfer the weight of the structure to the ground and prevent the structure from sinking. The thickness of the footing provides the footing with the strength needed to support the weight of the structure. In modern construction, a footing is usually 16 to 24 inches wide and 6 to 16 inches thick, and made with poured concrete that's rated to withstand 2,000 to 5,000 pounds per square inch of compression pressure. The dimensions of the footing may vary according to the soil conditions under the structure, the weight or load placed on the footings, and construction style of the home. For example, in a case called Allen versus Wilkinson, the Maryland Supreme Court dealt with a suit for the breach of implied warranties for failure to grade the lot on which a completed house bought by the plaintiffs from the builder owner and for failure properly to construct the footings, foundations, basement walls, and floors and drains, and for failure to waterproof and provide adequate drainage. Similarly, a plaintiff called a licensed building contractor who testified that upon inspection of Mrs. Mazzone's house, he had observed cracks in the brickwork which, in his opinion, had resulted from an abnormal degree of settling caused by the placement of the foundation footings on fill dirt. Based on his knowledge and experience as a building contractor, the witness characterized the building as being inconsistent with the exercise of that degree of skill ordinarily employed in the profession. The case was Shaw versus Peterson, a 1986 decision of the Georgia Court of Appeal. A continuous spread or strip footing can be found around the perimeter of the structure. It supports the weight of the exterior or foundation walls. In areas subject to seasonal frost, a footing may be placed below the frost line to prevent frost heaving that may lift and damage the footing and structure. A pad footing is like a spread footing, but it is usually used to support a single point of contact, such as under a pier or post. The pad footing is usually 2 foot by 2 foot square pad, 10 to 12 inches thick, and is made with poured concrete that is rated to withstand 3,000 to 5,000 pounds per square inch of compression pressure. For typical soils, a common 16 or 20-inch wide footing can more than handle the relatively light weight of an ordinary house. Of course, consideration must be given to the type of soils on which the footing is installed. For example, when built on soft clay soil, or if there's a soft zone under part of the foundation, or the soil is expansive, there can be trouble. A footing that performs well in good soil may not do so well in weak-bearing foundations. If the soil is soft, it is not uncommon to see excessive settlement where the bearing capacity of the soil is low. If there is a soft spot in the soil, widening the footing may be the simplest solution to avoid differential settlement. Increasing a 16-inch footing to 32 inches doubles the bearing area, making the footing suitable for soil with half the capacity. Of course, failure of a footing means failure of the entire structure. Foundations, on the other hand, in addition to footings, can be created using piles of wood, concrete, or sometimes metal columns that are driven into the ground and used to support the structure and prevent it from sinking. Piles are either driven down until they hit bedrock, or if bedrock is too difficult to reach, the piles are driven to a depth where the soil friction against the side of the pile is sufficient to prevent any further downward movement. The piles are connected using a continuous grade beam across the top of the piles, forming a base upon which the structure is then placed. Piles are used in areas where footings are not feasible or desirable, such as with poor soil quality or a high water table near an ocean or riverside. When a foundation fails, the failure is not always the obligation of the builder who installed the foundation. In Spearman v. United States, the U.S. Supreme Court, citing to J.L. Simmons v. United States in 1969, found that the appellant was entitled to rely on the accuracy and suitability of the government's specifications and on the engineering data it furnished the bidders. The government directed that the foundation be constructed in a specified way and must stand responsible for the results of its plan. This would work with any individual who sets up a plan for construction that results in damage and would be found to be responsible for the results of its plan. Masonry foundations are constructed from concrete blocks embedded in 3/8-inch mortar joints with reinforcing steel 9 gauge by 9 gauge for 8-inch and 12-inch thick walls. Complete failure of a masonry foundation can result in the collapse of the structure, while partial failure can cause cracking of walls and failure of watertight seals and windows. Cast-in-place concrete construction involves setting up removable forms for the pouring of concrete foundation walls. It's a common method for all 3 types of foundations: basement, slab on grade, and crawl space. Insulation is usually placed between the removable forms and held in place with a system of non-conductive ties. Then concrete is poured on either side of the insulation. Steel rebar is generally used to add strength to the wall. Once the concrete is cured, the forms can be removed and used as many as 3,000 times with minimum maintenance. Some manufacturers construct precast concrete foundation walls or panels off-site. Most of them are pre-insulated with rigid foam board as well. The panels typically come in lengths of up to 60 feet and in standard heights of 4, 8, and 10 feet. Once constructed, they're transported to the building site. A crane is needed to lift them in place. Precast concrete panels can not only provide high values, but also structural integrity and termite protection. Slab on grade is a concrete floor slab that is poured directly at grade and acts as the first floor, subsurface, and foundation. The slab is usually supported by continuous spread footings or piles and grade beams. Some builders and architects use the slab on grade as the finished floor of a dwelling by polishing the slab to a high shine that avoids the need for carpet, hardwood, or artificial wood flooring. Like footings, failure of a foundation can and will usually mean failure of the entire structure. This video was adapted from my book, Construction Defects and Insurance, Volume 1, 2nd edition, which is available from Amazon.com. If you found this video to be interesting or useful to you or your colleagues, please pass it on. It's free. And please also subscribe to my YouTube channel, my Rumble channel, clicking on the like and the Rumble buttons as you do, and also subscribe to my blog, my Substack publications, and my locals community so that you can learn about future videos and future blog postings. Thank you for your attention.